Hello, do you know intermolecular forces play a big role in our daily life, and that's what we're going to present. Presented by Umi Shohada, Akila, and Akila. What is intermolecular forces? Intermolecular forces are known as non-bonding forces that exist between molecules, including forces of attraction or repulsion.
So, what we are going to share in this video, first, intermolecular forces, second, physical properties. London dispersion forces. The forces are weak but exist in all atoms and molecules. At any instant, one side of the molecule has higher electron density while the other side has lower electron density. Attraction between instantaneous dipole-induced dipole forms London dispersion forces.
Dipole-dipole forces. A dipole-dipole forces exist between polar molecules. The positive pole of one molecule attracts the negative pole of another. The strength of dipole-dipole forces depends on the dipole moment of the molecule. Dipole moment gives rise to the degree of polarity. The higher the polarity of molecules, the stronger the forces.
Hydrogen bond is intermolecular attraction between molecules which contain a hydrogen atom covalently bonded to a small and highly electronegative atom such as nitrogen and hydrogen, oxygen and hydrogen, or fluorine and hydrogen. Acetaminophen, or known as paracetamol, it is soluble in boiling water, ethanol, methanol, ethyl ether, and acetone. However, it is insoluble in ether and benzene. This is due to light dissolve-like properties. This is the molecular structure of acetaminophen. Because electrons are moving at all times, there will always be London dispersion forces present between all molecules, including acetaminophen. Dipole forces act upon a pair of acetaminophen molecules because both acetaminophen molecules are polar. Oxygen and nitrogen are both more electronegative than carbon. The more electronegative atom pulls electron density move towards it, making it more partially negative. Hydrogen bonding acts on a pair of acetaminophen molecules because the hydrogen in one of the molecules bonds with the oxygen in the other. Hydrogen bonds are stronger than the above two forces. This creates a powerful forces that is difficult to break. So, in this figure, we can see the hydrogen bond that exists between a pair of acetaminophen.
Next, acetylsalicylic acid. It is known as aspirin. It is a drug used to treat pain, inflammation, or fever. The molecular structure of acetylsalicylic acid is shown as below. London dispersion force. Acetylsalicylic acid shows its dispersion force when the aspirin molecule is adjacent to another aspirin molecule. This force is sometimes called an induced dipole-induced dipole. D is the weakest type of forces. Dipole-dipole forces. These forces will occur when the slightly positive end of one polar molecule of aspirin is attracted to the slightly negative end of another polar molecule of aspirin. Thus, it has higher melting and boiling points than other forces and requires higher energy to break the bond to achieve the gas state. Hydrogen bond. Hydrogen bonding occurs between the oxygen atoms of aspirin molecule with hydrogen atom of another aspirin molecule. This hydrogen bond causes the changes in physical properties because hydrogen bond will hold molecules and increase the stability. So this is the diagram show the hydrogen bond between a pair of acetylsalicylic acid molecules.
Ibuprofen. The trade names of ibuprofen is Advil, Brufen, Nurofen, and Motrin. Ibuprofen most common use is as reducing hormones that lead to inflammation and pain in the body, reducing fever, and cure pain or inflammation that is caused by many factors like headache, toothache, and many more. So, this is the molecular structure of ibuprofen. Dipole forces in ibuprofen is occur when end of its molecule have a slightly positive charge and slightly negative charge and it attracted to each other. The carboxy functional groups create a hydrogen bond between the hydrogen and oxygen, while London dispersion force is everywhere within the molecules. So this is the comparison between these three drugs in terms of solubility in water, where acetaminophen is more soluble than aspirin and aspirin is more soluble than ibuprofen.
In terms of melting point, acetaminophen has the highest melting point. This proves that intermolecular forces in acetaminophen is the strongest when compared to aspirin and ibuprofen.
Created using Powtoon.